Okay, so I think we can start now. So welcome everybody. My name is Marco Bertini, and I will be the host for the webinar. And I'm going to talk about a couple of applications that help to increase the engagement of museum visitors through gamification. This webinar is going to be recorded, and you will find out the recording on the YouTube channel of ReinHerit. The webinar is a part of a series of webinars developed within the ReinHerit project. That is a European project that aims to improve and disrupt the current state of the art in the cultural heritage sector, providing applications, good practices, courses, and such. So you can find more looking on the ReinHerit website. Okay, so regarding these applications, I'm going to talk about strike pose and face fit applications. Look at how computer vision can be used to create new types of interactions with the users within the domain of cultural heritage. If you're interested in AI and computer vision for cultural heritage, I suggest to look at our past webinar, where we discussed about this type of technologies and how they can be applied to the cultural heritage domain. So let me start talking about an element of the ReinHerit project, that is the ReinHerit Toolkit. So the goal of the project within this task of the ReinHerit Toolkit is to develop a set of digital applications and digital tools that employ advanced technologies, AI, Internet of Things, webinars, mobile development, for easing the development process of applications in the cultural heritage domain. So our aim is to create these applications to help professionals and visitors to interact with performance environments as intelligent guidance tools that may understand the interests and the behaviors of the visitors within a museum, as gamification and learning-based tools, like the applications that I'm going to present today, as tools to discover relationships between and similarities between artifacts in the digital collections of museums. So in the toolkit, there are several applications that are going to be developed. And for these applications, we provide webinars. So the webinar of today is related to a couple of these applications. You can expect other webinars related to these other applications that we're going to release. Everything is going to be stored on the so-called digital hub of the project. How do we develop in general this application? We follow an open source development. The applications that I'm presenting to you today are open sourced, and you'll find the code to try them, extend them, adapt to your own needs on the digital hub next week, around Thursday. Our application employ advanced tools like AI and computer vision. We don't want to develop standard application using basic ICT technologies. We want to create interactive tools. So we want to engage with the user more, having a user that acts and our application respond to the needs of the user. And then we develop these applications trying to be mobile first and then web first. That means it's possible to follow a bring your own device approach to release and use these applications. So we have been inspired by other AI tools used in museums, following a human-centered approach. We want to try to provide new points of view or perspectives about collections and create interactive experiences if possible, phygital experiences if possible, and try to use an emotional engagement to motivate learning. So let's start from the main idea of the applications that I'm presenting today. Gamification. Gamification is a process where we exploit the strategies and the dynamics that are used in games into scenarios that are not really games, like the visit of a museum. This type of approach has already been used in many other domains, like in marketing, industrial training, entertainment. So our idea is that it's interesting to employ it also within the cultural heritage domain. So we think that cultural heritage can benefit from a gamification approach because it increases the engagement of the visitors. And it's possible to make the visit more entertaining, for example, for certain types of users, young users, that are more keen or have more familiarity with this type of approach. And we want also to help museum to move from a traditional approach of look, don't touch, towards something that is more play, interact with stuff. Moreover, it has been observed in the scientific literature that the availability of tools like gamified e-guides provided to the visitors contributes to the sustainability of museums. So in this webinar, I present two applications designed specifically for cultural heritage domain using gamification. The apps can be personalized by you, if you're interested, to provide new types of interactions apart from those that we have designed. Because you can consider these applications as a sort of Lego boxes. So you can rebuild new stuff, changing the position of the Lego blocks that we are providing to you, or simply create a different look and feel of the application, keeping the main logic of the applications. So let's start from the inspiration of this application, the main idea. So there is a scientific theory that has been already proven in several experiments that the brain of primates, it was initially experimented on monkeys, and it has been proven to exist also in the human brain. There are mirror neurons, so neurons that are activated when we observe the execution of an action performed by other people. So we are putting ourselves in the shoes of the people in front of us. And these mirror neurons are thought to help us to understand the actions, the intentions, and the feelings. And the very same neurons fire also when we perform an action, similarly to what we see in the others. It has been proposed that such neurons are the basis of our compassion and our empathic experiences. So the idea of this application is to exploit exactly this type of feelings, this activity of these neurons to provide a deeper understanding of the artworks. We have not been the first one to propose this. Actually, another type of inspiration for us was a couple of applications implemented at the Cleveland Museum of Arts. One is called Strike a Pose. So visitors, as you can see in this image, were asked to replicate the pose of an artwork and given back a feedback of how good they are. And people were asked also in this museum to make a face, and the system retrieves artwork where a similar face and a similar expression is implemented, is designed. So here, the face and the expression is used as a tool to navigate within the collection. Our proposal is somehow to follow and to expand this type of interactions, exploiting the empathic experience of replicating poses and expression, but with several key changes, several improvements. First of all, in our idea, we want to implement this experience as a challenge. Why want to have a challenge? Because this helps to increase the engagement while performing it. And we have already observed, especially when performed by young people, how challenges have become so common on social media. So a challenge is a key tenet of the gamification. We play for the challenge, after all. Then we want to create user-generated media based on the interaction. This is interesting because it helps to increase the engagement on social media. The users themselves became ambassadors of the museum. And then we want to use state-of-the-art AI techniques, computer vision techniques, that can run on mobile devices. This allows to follow a bring-your-own-device approach, so that it's not necessary for a small museum to provide an installation, as in the previous case. So I'd say that these three main changes extend the work, for example, of the Cleveland Museum of Art, still following the main idea of having an empathic experience. How this application works? They are based on computer vision. And the computer vision that we're using is based on something called deep learning. I would refer you basically to our previous webinar on AI and computer vision for cultural heritage. Here I'm just reminding in a few slides a few key elements of computer vision and machine learning. So machine learning is a technology that helps to learn, categorize, and predict some elements based on data. So it means that no programmer explicitly writes the instructions on how to behave inside the program. We provide data and labels, and the machine itself learns how to react. Within machine learning, one of the most modern and most effective technologies used to implement machine learning and computer vision is the use of deep neural networks that are artificial neural networks that are more or less mimicking some aspects of the functionality of the human brain. And the building blocks of the neural networks used in computer vision are typically some mathematical operations called convolution filters that are filters that understand some interesting and relevant visual elements out of a real-world image, filter and create higher level representations out of it, going through many layers. So these many layers are the cause for the deep adjective. And in this way, neural networks are able to perform high-level computer vision tasks. In these examples that you see, you can observe how one of these neural networks is implemented. So you can observe at least the many layers that are part of it. And more in general, what neural networks learn. You can observe in the bottom part that I am highlighting what are the objects that neural network learn to recognize in the different layers of the neural network. Out of the many different types of neural network used for computer vision, in these applications, we are using two types of networks. One for pose recognition. Pose recognition means that a neural network is able to understand the pose of the whole body, of a head, of a hand, understanding where are the joints of the skeleton. Here in these images, you can see some outputs of these neural networks. So a neural network observes this image of the two guys in the car and understand how probably the skeleton of each of them is in the image and understand where are the joints, the main joints. You can see it happens also for the hand. And for the head, we can understand where people is looking at, either with a full head or only looking at the eyes. Then the second task can be applied to faces is to recognize where landmarks are in an image containing a face. So the idea is we're performing a task that is very similar to that of pose estimation. But unlike pose estimation, where we have to guess the joints of a body, we understand where are relevant points of the face. Basically, we can understand through it the whole pose of the face, the pose of the eyes, of the mouth, of the eyebrows, and even create a whole mesh and compute the surface of a face. If you have ever used applications like Snapchat or some filters for your own selfies, there are very good chances that your application used neural networks that perform exactly this task. So out of these technologies, we have created our applications. Let's start from the first one. I won't get into engineering technical details, so do not worry about that. I am a computer engineer, but I'll try to present these applications from a relatively high-level point of view. But I want to give you an idea of the difficulties and how they are implemented so that you will learn how you can adapt and extend these applications for your own tasks. So Strike a Pose is a web application that performs analysis and evaluation of human poses and compares the pose of a user with that of some painting or some statue. This application, being web-based, can be used on the device of the visitor, or you can use it as an installation. The relevant part is that being developed to run on a mobile phone, this application does not require some special hardware. So it means that even in the case of an installation, you really need a simple PC. You don't need a powerful workstation. In general, how does it work? So once registered, the user is challenged to reproduce in sequence the poses of some artworks from the museum collection. Once all the poses have been matched, the application allows the user to generate a video that can be saved for any social sharing and provides information on the artworks. The idea is that we are creating a video that looks like a TikTok video so that it can be shared. The poses to be matched can be organized in different sets of challenges. For example, we can have a challenge that asks to replicate poses using the whole body, or we can have challenges that require only to use the torso. So we can allow also people with disabilities, with certain disabilities, to play. Or we can have challenges based on some thematic collection or on some exhibition that is running in the museum or that is deemed to be of interest by the museum curators. So let's start to see some screenshots and animation of this app. So being a mobile application, the interface has been originally designed to run on smartphones using a vertical layout, as someone will use it to take a selfie of himself. While for the installations, the layout is horizontal. Of course, if you have also an iPad, you can run it both vertical or horizontal. We have a neural network that recognizes key points, so it's possible to match on the mobile phone the pose of the user and compute an overall similarity of the poses. This is useful because we can compute without latency in real time a feedback for the user. In order to create the game, you can see the percentage of similarity of the poses running in this example. Replicating the poses unblocks the next challenge, and all the poses give you the final video that is, of course, shortened enough to be TikTok-like, as you can see in this example. That means that we understand when the user has really matched the pose and get a little few seconds before and after. And this is an overall idea of the screenshots, but I'm going now to to see the whole application. Okay, I have a very good question. How does it respond to visitors with other types of disability, like a missing arm? That's a good point. So the current network will simply not recognize that type of disability, but it's possible for you to cater also for this type of disabilities by two ways. Creating challenges where simply there is no need to recognize one of the limbs. You can observe here in screen 2. Or better yet, if you want to use exactly the same other artworks like for the other challenges, you can simply change the measurements that computes the similarity, so to discard one of the missing limbs. It's just a matter, could be just a matter of easing the overall function that computes the similarity. So it's a simple adaptation that can be implemented by changing really a few lines of code inside the application. I hope that I've answered you, Paul. But you have posed a really interesting problem. If you are interested in this, I'd suggest to contact us regarding this aspect. So, what is the architecture of this application? Okay, you don't have to program anything, I guess. I'm unsure if you are programmers or you just go asking for some technical help by your colleagues. So the application is composed of two parts. There is a front end that is running on the mobile phone, and there is a back end that runs on a server. So the front end is based on JavaScript, HTML, CSS. So these are really basic web technologies. And the backend is implemented in Python using Flask, using REST APIs, and everyone we use it to store and create the videos for the user and to store the challenges. The backend actually is composed by a large number of technologies. Do you need to master all these technologies to use these applications? Absolutely not. We provide to you the applications ready to run. I'm showing you these details just in case you are interested in adapting and changing the application in later stages for your own organization. So we use OpenCV to create the videos, we use Flask to manage all the communications, and we use SQLite and SQL Alchemy to store the challenges. The front end is based on JavaScript, Bootstrap, and jQuery for the interface. We access the webcam, and all the magic of the computer vision, in this case, is based on TensorFlow.js. That's a framework for artificial intelligence. And it's a framework developed by Google, so you can expect that it will be supported almost forever. This TensorFlow.js, it's a special version of TensorFlow that is the flagship product for artificial intelligence by Google. And it runs natively in JavaScript. Okay, there is another interesting question. Who creates the challenges? The challenges can be created by the people that are managing the installation, the backend. I'm not dealing with copyright issues. So, for example, I expect that if you are interested in running these applications in a school, I think that you can use any type of material, because I'd say this is a fair use of such materials. Of course, if you are a museum, it makes sense to use your own collections in order to create the engagement. I think this type of application is very nice if it's installed or proposed to the users before getting to the main halls of the museum, like to prepare especially young visitors to what they are going to see after. So the interface has been designed to be responsive. So the same application runs on a large number of devices. These are really screenshots of the application now. It adapts itself to a tablet, to a mobile phone, to a portable PC, to a desktop PC, and such. So you can see that you can create an installation, or you can run it and propose to the visitors to run on their own devices. I mean, everyone has this type of devices every day. So the interface can be easily adapted. For example, you can adapt the color schema. In our example, in some of our tests, for example, we liked the idea of using the colors of some famous artworks of Florence, being based in Florence. You can adapt all the elements like the background images of the interfaces, or change a little bit the layout of the elements, as you can see in the bottom line of this image. Being everything based on HTML means that the cost for you to adapt to your own institution, to your own lab, to your own experience is very low. You don't need hardcore programmers to do that. It's a matter of cascading style sheets and changing the position of some HTML widgets. How do we perform the pose estimation? We have a neural network that receives as an input an image from the webcam, the image of the artwork. It computes the positions of the joints of a skeleton. So we look at neural network models that can be executed in TensorFlow.js, that is the framework for AI using JavaScript, and have low requirements for computational capabilities. So this is a task that you have to cater in general when you are developing these type of applications. Being web first, mobile first, it means that we must use neural networks that are designed for mobile devices. And in this case, we found out that MoveNet is a good neural network for this type of problems. This neural network comes in two different flavors. And if you look at many neural networks for computer vision, this is an extremely common fact. And these two variations of the same network means that one is smaller, so it's downloaded faster. It's faster in running. That means you can expect that even visitors that have low-end mobile devices can experience this application, but is less accurate. Then there is another version of the same neural network that is more accurate, but it's larger and slower. Perhaps this makes sense if you have an installation rather than a mobile device. So once we have these points obtained by the neural network, we have to perform a normalization. That means compute the average position of all the detected key points, normalize the position of all the points according to this average. This allows you to compare similar poses in different parts of the image. So you are not forcing the user to be exactly in front or on the side exactly as is the artwork itself. And then we can compute and compare the distances of the normalized key points between the reference image, the artwork, and the webcam image. And here is where you can work on further extending this application to cater for missing limbs. Since it's a game, you have to allow for some generous overall distance when computing these key points, or computing the overall distance, the global match with the pose. So remember, we are not trying to create an application that helps people perform gym, or some therapy, so they exactly have to take a certain position. It still must be fun, not too easy, because a game that's too easy is not fun, not too hard, because again, a game that's too hard is not fun. And then we use this distance to provide the feedback to the user. So here we can think of two different types of feedback. One is the bar that shows how similar you are to a certain pose. The other one that we have found out is quite interesting, and typically users prefer it, is also to show what the system is seeing. So showing the skeleton. We have observed that in many cases, these help the people to concentrate better in the replication of the pose. And this is interesting, an interesting aspect of the game itself, because we are interested in asking the people to really get into the artwork and observe it with new eyes. After the matches and the challenges have been passed, we create the video using the images that were stored on the server. We know exactly when the person did the best match, and then we keep and use some frames before the match and some frames after. So we are cutting a short sequence, and then we compose the video with the artwork. And here you can see some examples of use of the application and the videos that are created. Videos must be short, they must not be too boring. And the cutting sequences of actions, it looks like people are dancing here. So another nice question, does it work with artwork that is not 100% mimetic? The answer, I'm sorry, it's no. No, because these neural networks have learned the appearance from real humans. So luckily we can't mimic that type of artworks. I guess that somehow probably a Etruscan stretched statuettes could work, but this is an interesting idea. We should really try also on that type of artwork. I invite the person who wrote it down in the chat to contact me, because it's a nice task. Good idea. So where do we provide the information regarding the artworks? Okay, here is another example with a different layout. So you can provide the information on the artworks when getting the video, when giving the video back to the user. So videos, even if they are short, they may be quite heavy, so we let the people download them. And here you can see how to provide the feedback. This is one of the aspects that you may change to adapt to your own needs. So we have created some variations of this app, like extending the solo version on a 1-versus-1 mode. This requires to add some more elements like virtual rooms to let people compete. And this is an example of a competition between two users. Let me jump straight. So you can invite your friends. Pick the number of rounds, pick the number of poses per round. And then the one who is faster or better wins. So here, apart from this idea, what's the message? Out of these applications, you can create new versions of the applications. Invent something that is interesting, or you can create new types of interactions. So really consider this application a Lego box, and you can create your own out of it. In order to ease the usage of this application, we have Dockerized them. If you don't know what is a Docker, it's a tool that helps to recreate a system on a different computer. So it means basically you don't have to work too hard to reuse these applications. It's just a matter of a couple of lines in a terminal. So let's move on the second application, FaceFit. So this application provides the gamification of paintings and personalization of paintings, looking at portraits. The idea is it runs both on smartphone and on desktop, so it can run as an installation. The goal is to replicate the pose of the head and the expression of some portraits, and then get a new image where the user is painted inside the painting. And in order to get these images of himself, you get also the information on the artworks. And then the images, again, can be shared on social network to increase the engagement on social network. So again, we use a faster than real-time neural network that predicts a number of 3D points for each face. We use these points to compare the pose of the face, the expression of the face, and then we substitute the face of the user inside the painting. So here is a video showing you an example. You can see a ghost face. This is a trick that we use. We had to experiment with this type of interaction. So the user sees like a ghost version of his own face. And since it's a ghost version, you really understand better the pose of the painting, and you get more focused, and you spend more attention on the expression in the painting itself, rather than providing other types of interactions. Like here, drawing the mesh of the points as drawing the skeleton in the previous application doesn't really work, because the mesh of the point is too dense. They are more than 400. It's masking too much of the artwork. So you are not really understanding the artwork itself. And how do we provide the feedback to the user? In addition to the ghost face, there are some bars instead of one that let people understand how the face can be rotated in order to match the expression. The architecture of the application is much simpler than the previous case. So the standalone version is a monolithic application in Python, and the web version instead runs using JavaScript and TensorFlow.js, but it requires also to implement some computer vision on the backend. This is relevant when designing AI and computer vision applications for mobile phones. We always have to account for the fact that typically these devices have reduced advanced capabilities than desktop versions. So often you have to rely on some backend to complete the computer vision part. But you must be careful to design the application so that the most reactive part is running on the device. You want to reduce the latency. You don't want to have a slow application where the answer to the user is given with a slow network. It ruins the game experience. So running the neural network on board, it let us compute the match, and then we simply perform the face fitting of the user in the painting on the backend. At that point, the user has already won and is getting the image. So it's not anymore a problem of latency. So from face to point, as I said, we have this network that extracts 3D points, a very large number. It's relevant for this very large number since it helps us to recognize the position and the state of the eyes, of the mouth, and of the nose. The face matching basically looks at how the position of the head is. So out of the meshes, we understand if somebody is looking up or down, right or left, and if the head is turning towards the shoulders. So we have 3 axes of rotation for the head. Once the pose is matched between the user and the artwork, we can check and evaluate the expression. The expression is evaluated according to the open and closed status of mouth and eyes, and it's evaluated only once the whole pose is matched. This task can be executed on mobile devices, and this is the relevant part to have a reactive interface. So now there is the part where we create the merged image. So there are 2 main tasks in order to paint back the user inside the artwork. And here I can answer one other question: how well does it work with non-white user, non-white paintings? So we have tested with a very large number of persons of different nationalities, and apart from nationalities, with different facial features and skin tones and genders, and I say that it works very well on the side of the user. Since so far we have tested also with different genders on the artworks. Perhaps we could play a little bit more with different non-white paintings, but really this network has been designed to cater exactly for inclusivity. It was a network designed by Google originally, so you can expect that this network will work very, very independently from all these issues. So we can expect this application to be inclusive, I'd say. You can be quite safe on that. I hope I have answered this, and let's go. How do we perform the merging? Well, the first step is to understand the color palette of the painting and adapt the image of the user to that color palette. So it's a sort of a color correction of the image that is got from the webcam. Then we need to morph the meshes. So the 3D points of the artwork with the 3D points of the webcam. So we compute all the transformations of all the triangles of the mesh of the face of the user onto the 3D mesh of the painting. So these allow us to create a 3D morph. And then we cut out only the face of the user and we mask it. So we compute an overall mask that understands how to merge the face of the user onto the painting. We perform a bit of image processing so to avoid too sharp cuts out. The idea is that the user must feel as if it was really painted inside. So we have to avoid too rough matching of the mask of the person. And we also try to recreate the brushes and the cracks of the painting, computing a sort of noise out of the artwork and applying the same noise, that means the same brushes, signs of the brushes of the painting onto the face of the user. So it's not only a matter of matching the color palette of the painter, but also to match the style of the brush strokes of the painting. So here is the whole process that I've mentioned so far regarding how to match. We get the triangles of the mesh of the face, we warp the user onto the mesh of the painting, we cut out the relevant part to be merged, we create this mask so to smooth the merging, and then we adapt it to the painting itself. And here is another example, so you can see that it works also with glasses somehow. Of course, glasses are a bit harder, but I think also in this case, the result is quite interesting. And here is what the user gets once he wanted to get his own images. So you get the image by email with the details on the artwork that you got. So where can you find these applications? So we presented this application in the most important conference in the world on multimedia, and we got the Best Demo Award, honorable mention for these applications. And basically, some hundreds of people, of experts in multimedia, played for a whole day with these applications, as you can see here. And it was interesting for us to experiment with such a large number of persons because we really learned something. For example, people started to exchange their own images during the gala dinner. And we observed also an interesting fact that typically young users have some fun in exchanging their own gender in the artworks, while some other users instead feel it more uncomfortable, especially if they have a certain age. But as I said at the very beginning, these applications are open source. So next week, around the middle of next week, you can find the full source code of the applications on the digital hub of the ReinHerit project. So the idea is that if you're interested in them, you can download and adapt them. You can discuss the application on the ReinHerit forum. And if you need information or help, just contact us. You'll find information on how to install the applications on your own system, how they work, and if you have more information, if you want more information, if you have questions, please contact me at this email. So now I'd like to ask you some questions, and let me start. Actually, let me ask you. A short survey with a few questions. Those are multiple choice questions. So hopefully you can see the questions, and I invite you to vote. We are very interested in your questions. Let me check also if there is some other question I didn't answer. Please vote. Yeah, you can give more than one answer. Everyone is multiple choice. The question is multiple choice. Okay, many of you have voted. Please, the last ones. It's interesting to get more votes, as many as possible. So there is one more question. So far, the experiments have been done in the computer science, multimedia, and computer vision communities. So we really should, we are releasing the applications right now, so we should really adapt them and experiment them. Our idea is that these applications could be used, for example, in sort of Van Gogh yourself style. So this could be another way to measure the engagement. But if you are interested in this type of experiments, we would like to help you. We are available to help. Okay. So I guess that everybody wanted to vote as voted. Okay, so let's share the results so we can see them all. So yeah, I see that your opinions are quite interesting. Improve the visitor experience. It's, yeah, I guess also for also my opinion, it's a very good it's a very good motivation. Okay, motivate learning. Yeah, rich new business. I think this type of application works really well with young people, but whenever we have experimented them on many different types of users with different ages and different backgrounds, everybody was laughing a lot and having fun. So really a lot of people is interested in them. Okay, so if you are a museum professional, as I said, you'll find out the applications on the digital lab, but please contact us if you need any help on how to run them and how to experiment on them. Please contact us. We will help you. You can count on it. So I see that, okay, many people would run it. Regarding other gamification apps, I have to say that at least in our development plans, the other applications have less gamification, but I hope that at least those who voted for FaceFit and Strike a Pose will really play with them. Okay, so if there are no other questions from you in the chat, I invite you to join the forum. You can see the button on the top. So please contact us either in the forum or contact us also directly. Also contact me regarding the release and how to use this application. If you are interested in experimenting them, writing papers, if we can help you, for sure, contact us and we'll do our best to help you make these experiments. And remind, these are just the first applications that we are releasing. There are many more coming, like applications to inspect and analyze the details of the artworks. So to be an active viewer of artworks, applications to manage and search digital collections, and chatbots implementing visual question answering and such, So these are just the first two applications that we are releasing. If you have other interest, you'll see them on the ReinHerit Digital Lab. Or if you're interested, contact us again, either on the forum or directly. The video of this webinar is going to be made available on our YouTube channel. And okay.